Unit 2 is logarithmic equations and expressions. So 2.1, we're going to start with just evaluating logarithms. This is something we learned in Algebra 2, but I know it's been a couple years. So we need to go back and say, or remember that a logarithm is really just finding a power. It's a power to which something is raised in order to get some other number. It's really the inverse of an exponential function. And so you'll see here that I wrote an exponential equation and then turned it into a log. These two things are equivalent. They kind of are opposites or undo each other. So if I say 2 to the third power equals 8, which is true, because 2 times 2 is 4 times 2 is 8, I could rewrite this as log, and then you put a little number down here, which is the base. The base of the exponent is always this big number. Of 8 is actually this answer in my exponent is 3. 3 was my power. So you'll see here that any log problem is really asking for what power does it get raised to. So let's go over here and look at number 1. This says log with a base of 3 of 27. You're trying to figure out what does that equal, meaning what power does 3 need to be raised to. So we always rewrite logs as here's my base of my exponent raised to what power needs to equal this number of 27. Well, 3 times 3 is 9. 9 times 3 would be 27. So it would be 3 to the third power equals 27. All they're wanting is the power. So my answer would be 3. So when you see this, you need to think this is asking 3 to what would make 27. Number 2 just says log of 1. Well, it's missing a base. Come back over here to the left. We need to know what a common log is. A common log is when they just use the word log with no base. What you need to know is that actually it has a base of 10. So you'll see the log button on your calculator. Whenever you use that, you're dealing with bases of 10. Because think about scientific notation. 10 to the third, 10 to the fifth. That uses powers of 10. So this one I'm going to add a 10 in. I'm going to also put x here. That's just my preference to make it more of an equation. But you're asking yourself 10 raised to what power would give you 1? You might think, well, how do I go from 10 to 1? It's not a negative, because negative powers actually sink things to a denominator, but hopefully you remember that anything to the 0 power is 1. So it does not matter how big or small the number is, anything to the 0 power is 1. So x must be 0. All right, number 3 has this ln. Come back over here to the left. ln is a natural log. Natural logs are really just log with the base of e. E is an irrational number. It's about 2.7. It keeps going. It doesn't stop, kind of like pi. Doesn't repeat, so we just say it's approximately 2.7. So it's a number. When I see this, I'm going to rewrite natural log as log base e. That helps me. And then to see of e to the third. I'm going to set it equal to x again, and I make it an exponent. E to what power is e to the third? Well, the nice thing is your bases match. So all you're asking is e to what needs to be this? Well, this must be 3 as well. So you're wanting to know that it's just a power of 3. Number 4, 7 to what power would give you 1 over 49? Well, I want you to think about 7 squared would be 49. 7 to the negative second power means that that sinks that to the bottom, and that would be 1 over 49. So x must be negative 2. You could always check that on your calculator. So 7 to the negative second. It'll get you a decimal, but we can hit math, enter, enter, and it changes it into a fraction. Okay, so fractions really mean that the power must be negative to make it be an inverse or reciprocal. Number 5, natural log. I'm going to rewrite log base e of 1 over e to the fourth. I don't like 1 over e to the fourth. I'm actually going to change that to be log base e, and I'm going to move it up, but now that means it makes the power negative. So I remember that this line makes the power negative whenever I move an exponent from top to bottom. Make it your equation so you can figure out how to write it as an exponent. E to what would be e to the negative fourth. Well, these must match, so x would be negative 4. So my whole goal is to think, I want this base to match this part, have the same base. So then all I got to do is just have the same power. So number 6, that's going to be handy. 4 to what power would give me this? That's very complicated. But if I could make this be 4 to a power, that would make it a lot easier. So I'm going to figure out 4 to what power would make 256. 4 times 4 is 16, times 4 is 64, times 4 is 256. So 4 to the 1, 2, 3, 4th power. So I'm going to have 5th root of 4 to the 4th power. Then I'm going to rewrite this as an exponent. So it'd be log base 4 of my base is 4 to the 4/5 power. This is a rule that we learned. Fractional exponents are really radicals. This is called the index that goes to the denominator of the fraction. So now it's really simple to see 4 to what power would give you 4 to the 4/5. So x must be 4/5. Number 7, similar but with e. So this is log base e. And I want to rewrite this as e to the 3/5 power. So most of you will be able to see what the answer is. E raised to what equals e to the 3/5. It must be 3/5. Last one, 32 to what power would be a 4th? That's a harder one for me. I can't think of how do I get from 32 to 4. I know that I'm cube rooting, 4th rooting, 5th rooting, doing something, but I'd rather not even think about it. So on this one, I would do change of base formula. And that is over here on the left. I've already written it out for you. Change of base allows you to actually figure out any log that you need to. So you could have done it on other ones if you get stuck. But what it does is it takes log of b and divides it by log of a. And the way I can remember is because b is above the a, so I can picture it being on top in the numerator over the log of a. So comes back to your problem, I would be taking log of a 4th and then dividing that by log of 32. You can put 1 divided by 4 like that, or you can put 0.25 divided by log of 32. Gets me a decimal. Let's change it into a fraction. That's negative 2/5. So what that allowed me to do was figure out what power is needed. And you could still check it. You could say, okay, is 32 to the negative 2/5 power give me a 4th? Let's check. 32 to the negative 2/5 is a 4th, so it works.